Andy.
Good afternoon, good morning, wherever you are. It's great to be with you. It's Andy Rayner here from Nevion. I'm based in the UK on the east side, just by the sea. And I'm very excited today to have as our guest Jean-Baptiste Laurent from intoPIX. Hi, Jean-Baptiste.
Hello, Andy. Hello, everybody. Thank you for attending this fireside chat. It's very exciting.
Yeah, I'm hoping that most of you will be able to feel some of the warmth from the fire as it burns beside us. You know, we've been stoking it up for the last hour to get it nice and warm and ready for the session today. So what we're going to be doing is we're going to be having a chat for probably 40 minutes, at which point we will then look at any of the questions that you've posted on the chat window. So if I can encourage you, if you'd like to make any comments, then do feel free to do that. And yeah, that'll be really great. So we'll come to them at the end rather than kind of interrupting as we go. I promise we will finish, but well before the next hour, because not only am I aware that the Simply Virtual Online event for this year is actually starting imminently, but we also have with Nevion, we're doing a joint webinar with Cisco on SDN control, which is starting on the next hour. So if you're free and fancy even more of this exciting stuff, then do feel free to join us for that as well. We can get you the details. Maybe Cosimo can post the details for the up and coming webinar on the next hour on the chat window whilst we talk. So just a further very brief bit of background introduction. So I say my name's Andy. I've been with Nevion for I think 10 years and 11 days now. And before that, I spent 22 years working for BT, British Telecom in the UK, heading up their broadcast technology development and architecture team. So that's me and my background. JB, do you want to introduce yourself just for a few seconds and your background?
Thank you, Andy. So I am Jean-Baptiste. I'm with intoPIX for almost 15 years now. When intoPIX started as a spin-off from a university in Belgium, really focusing on the compression algorithm, at that time JPEG 2000 for digital cinema. And I move from a product management to marketing to sales, and today I'm a bit of all these topics.
Excellent, and we're very excited to have you joining with us today, so that's great. A couple other bits more of information for you before we jump into the topic of choice for today for our conversation. First of all, resources. We've put a wealth of resources on the Nevion website, which you're very welcome to avail yourselves of, including the latest 10th edition of our virtualization and IP for media production booklet. If you hop over to nevion.com, you can get to all of the information, along with a whole load of the other webinars and tutorials, etc., and white papers that we've made available. So do feel free, preferably after we've finished this, to go dive off and go and do that. Okay, I'm going to spend a couple of minutes just setting the scenes with a handful of slides. Then we're going to kind of dive into the conversation. So just to give the context of the space of what we're talking about today, this is a diagram that I think I've used in pretty well every presentation I've given for the last 8 months, because I think it neatly encompasses kind of the evolving space which we from a Nevion perspective are using to cover what I call distributed production. You'll see that encompasses IP local area networks within a facility. It incorporates wide area connectivity, both being used for federating facilities together, but also federating facilities into OB vans and to facilitate outside production, remote production as well. And then there's been a big addition that we've kind of added to it this year, which is the cloud piece, because it goes without saying that more and more infrastructure is being moved towards the cloud, and that certainly, where appropriate, is a natural home for quite a few elements of the broadcast production chain, more and more so as we move forward. So we've added that into this picture. Just a couple of quick comments on on standards as well as we go. Again, many of you will have seen me present this picture before. I'm not going to explain this whatsoever. You're very welcome to look at one of my other webinars that does a lot more unpacking of some of this. But really, just to point you to the context of some of what we're talking about today, is the second row down on the left-hand side there is what we call the -22 part of the 2110 suite, the compressed video, because that is, if you like, that's where we're kind of shoehorning in the compression elements that we're talking about within the conversation today. And just a plug for a couple of other working groups that are ongoing at the moment, which again are making use of some of the technology we're going to be discussing today. In the Video Services Forum, which is an international body which I would encourage you all to get involved in if you're not part of it already, we have got 3 activity groups which are all entwining at the moment, but the 2 that I'm most involved in are the ST2110 over WAN, which is how we carry essence-based live media production over wide area networks, and the GCCG, which is tough to say sometimes, the ground to cloud, cloud to ground. And very basically, that's actually all about how we actually get content to and from real-time content to and from cloud infrastructure, and also how we interconnect between virtual processing functions within the cloud. And obviously, as you all have guessed, compression is likely to play a fairly big role in some elements of that as well. So that, again, highly applicable to what we're looking at today. Just before we open the full conversation, two quick slides. First of all, this just amuses me. It's a legacy that we're still living with very frustratedly nowadays, but 80 years ago, some people had some ingenious concepts of compression, and interlace effectively was one of the, I think, probably the earliest form of doing video compression. You send half the information at one point, half the next half a little bit later, and give the illusion of a higher temporal rate with more information. Ingenious, but we are left with a challenging legacy, especially when it comes to some elements of compression. And finally, as we dive into our conversation, a good friend of mine that's been in the industry for a long while, now resident in the US, Neil Bryden, said back to me 24 years ago, you only have one chance to make a first compression. And I think just bear that in mind as we go into our conversation here, because as you think about all the concatenated elements of a broadcast chain, is actually really important to think about what happens as we actually introduce compression there. Okay, so that's very good. I think that's all I want to share for now in my Fireside slides. So I will drop mine there. Hopefully you'll be able to see us all and come back to it. So JB, now I've done that little introduction. Thank you very much for joining us. Do you want to start by talking a little bit about the journey of compression that you guys have been involved in, and I guess specifically wavelet compression, because that's obviously been, I guess, a fairly large bit of what you've done. And maybe you can just talk to us a little bit about the journey, but I guess your first adventure was in JPEG 2000.
Yes, that's right. I would say from the beginning, I don't know if you see my screen, but I'm starting to share.
We've got it.
Yes. Okay, super. intoPIX is in a quest of gaining efficiency, and the journey started for the company on JPEG 2000. JPEG 2000 was really attractive as a codec because it was one of the first standard-based codec using wavelet, and wavelet compared to traditional JPEG codec or MPEG-2, MPEG-4 using DCT, was offering a smooth artifact and avoiding these famous blocking the square that people didn't like too much when using too much compression. It has been a big success first in the digital cinema, and it's still the distribution codec used in every theaters. And it made a road into the contribution. So for wide area network video streaming, mainly in the transition from SD to HD, if you look a little bit backward. Uh, I mean, looking at the evolution, like the slide I'm sharing here, we know we have billions of pixels to manage, and we move to higher resolution. Camera resolution are also getting a bigger bit depth requirement. Also, we speak about high frame rate. Moving from interlace to progressive is also impacting the level of data. If we just look at I mean, these days with the COVID-19, the internet traffic, particularly on video, like the thing we do now, it's amazing how much we need video and how much we need efficiency these days. And in that journey for intoPIX, with JPEG 2000 for the broadcast industry, we have been challenging ourselves to innovate in that road. And for those who are familiar, and Nevion is really familiar to that, we introduced the JPEG 2000 ultra low latency a few years ago that has been somehow standardized at VSF to reduce a latency that was something like in the range of 100 milliseconds or down to 60 milliseconds to go below 15 milliseconds at that time.
I guess just to unpack that journey a little bit. So, effectively, the place we're coming from, I guess, largely in 2020, apart from being locked down, is that very much, the usable bandwidth typically within studio facilities for most now normal resolutions, the bandwidth of the switch fabrics and the fiber interconnects, etc., is sufficient to actually typically not need to use compression within the production campus, if you like. Although it's fair to say various record and replay servers, etc., still typically use some form of compression as part of that. But it's the wide area. It's always been the wide area network that's the challenge. And even if I reflect on the UK situation, where quite a lot of our national broadcasters for HD are now, for the main interconnect between main facilities, are carrying HD uncompressed. That's kind of the cost for the wide area network and within a country has got to the point where HD uncompressed is viable. That's not true in every country. Certainly the tipping point, as I see it in the UK at the moment, is typically when we want to do 4K ultra high definition, then we're typically deploying compression for wide area networks. Now that's obviously for fiber connectivity. Depending on the other types of connectivity and the bandwidths that are available, then we are typically using that. And many of the deployments I've been involved in with key broadcasters in the UK and obviously many other places globally, we're using a lot of that traditional JPEG 2000 with the typically 3 field/frames of latency end to end in a large number of deployments. And I'm guessing, I was just trying to think of the timeline, but it's probably the order of about 12 to 14 years ago where we very first started to use the JPEG compression. So it's been a good evolution there. And then as latencies become more important, and I guess one of the drivers for that from our perspective, looking at the broadcasters, is starting to do more and more remote production where that closed loop delay becomes important. That's the journey to ultra low latency. So do you want to just unpack a bit what changed to get us from the traditional JPEG 2000 to the ultra low latency? What changed? How did we change the way we did the compression to make that work?
Oh, so I would say that was pretty simple. So we decided to basically horizontally split the picture in multiple what we call stripes, horizontal stripes, and to do a transport stream packetization of these stripes. This way, splitting the picture in 5 or 10, we were able to reduce the latency just at frame level or just below the frame. That was pretty efficient, but I would say for us as compression experts, we have been also challenged on other areas of from that evolution from JPEG 2000 to JPEG 2000 ultra low latency to find new ways to let's say, frankly, replace uncompressed, but preserving all the benefits of the quality and latency of uncompressed. And one of the big challenge we had is, there are two examples. There is the hardware side and the software side. In JPEG 2000, in the algorithm, it's not just because you split the picture in stripes that you will reduce its complexity. You still need to use like external memory, and entropy coding has still the same complexity to compress. And what we were really struggling is that this compression is solving an interface issue. And there is a cost approach and density approach that is very important for manufacturers and broadcasters. The number of 4K channel, for example, that you would support in one piece of hardware, one FPGA, for example. And JPEG 2000 was not really scaling at that level. The amounts of external memory was huge. The amounts of logic needed to perform the encoding and decoding was really large. So that was the hardware part. And the software part, also the entropy coding running on a bit-to-bit was not enabling a very high parallelism in software, and to achieve also low latency in software. And we could say that FPGA are reprogrammable. They are not really software as a regular CPU are. And moving to like one of the topic like cloud-based infrastructure, software become also important. And this has been solved with the evolution towards like the TICO compression that we submit at SEMTI, and later on, I would say today by the JPEG XS.
Okay, so so we've talked about JPEG 2000, we've talked about moving that to ultra low latency, which is basically just striping, and you get a pro rata reduction in latency by the number of stripes, roughly speaking. So moving from ultra low latency JPEG 2000 to TICO, what changes did you make then to actually make that step in terms of the compression and coding approach?
I think I have a slide just to depict a little bit
a picture speaks 1,000 words. Always slide.
Let me just show you that. Hopefully.
I see it. I see a change slide, but it's probably not the one you want.
Okay, so yeah, just to explain a little bit what change we did from JPEG 2000 to TICO in that analysis. We could say that a codec, you have three main steps. You have a first step that we call the transform. You try to decorrelate an information. So you try to reorganize information in a way that it will be much easier to compress it. And the coding is like the zip file. You purely code 0 and 1 purely bits of data to make it smaller. And then you apply a rate allocation to achieve the compression ratio you want. For the creation of a lightweight compression like TICO, we did revisit each of these steps. The transform, we are really expert in wavelet transform at intoPIX. So for example, in JPEG 2000, you had a transform apply on the full pictures that was taking this large number of lines and that you had to store. We try to simplify the transform. So we use, for example, a different transform than the one we used for JPEG 2000, because that one was consuming less memory and was much simpler in terms of latency. For the coding, JPEG 2000 was running on a bit per bit. We tried to find a way where we could group bits to compress them in a way that, offering more parallelism and more simplicity. And the rate allocation, we instead of applying a rate allocation that is in JPEG 2000 in a variable bitrate that you have to cap with a quantification that's per bit plane, that we decide to do an on-the-fly rate allocation, so that we don't need to wait for the last lines of pixel of the frame to send over the data over the network. So we just bufferize few lines of pixel, and when we can already send it over the network. And as constant bitrate is very important, we ensure that we always do that in a constant bitrate way. So you ask for 10:1 compression, you will on the fly always get a 10:1 compression in the network. That was also important to avoid overflow or underflow in a compression. Yeah, that's. I hope it's not too technical.
No, this is great. This is great. So, what attributes did TICO have when you'd finished it then? So, you know, in its usage. I mean, I know how we were using and still are using TICO for some applications. What was the sweet spot for the TICO variant?
I would say typically, moving from G2K to TICO, we somehow reduced massively the complexity, but also we did reduce the compression efficiency. I mean, it's a higher bitrate codec, so we were able to compress by 4 the uncompressed data. So if you had a HD baseband infrastructure like a 3G SDI a ready network or 2022-6 network able to transport HD 60 frames per second. Just by applying the TICO RDD35 on top, you were able to leverage the same network to carry a 4K video on it. And that was really the sweet spot of TICO.
Okay, yeah, and certainly I know a majority of the applications and the deployments that we've been using for TICO have been that nice squeezing, you know, a UHD signal into a 3G SDI type infrastructure, you know, be that a native 3G carrier pipe or just the equivalent bandwidth thereof. But that's been very good. Okay, so that takes us to TICO. So talk to us about how JPEG XS started and the formulation, because obviously it's a ratified standard, so it was developed by by committee. So can you give us kind of not all of the long and painful story, but can you give us like a 2-minute summary of how the baseline was started and how you built up to get to JPEG XS as it is today?
Yeah. So to create an ISO standard, you have 3 steps. So you have a first step that is the call for evidence. So you need to prove that there is a need from an industry, that there is no solution solving that need, existing solution for that. So we organize with the ISO JPEG committee some session. I think some of those who know him, Chuck Meyer, Mike Krung for AIMS also did participate to that to present the need of the industry. That has helped to establish the call for proposal. So it's somehow a neutral process where the ISO JPEG committee will issue a call for proposal, and everybody worldwide can submit a proposition. Then you go to the analysis of all the submitted proposals. For JPEG XS, there was 6 proposals. It was important to analyze if the proposals were meeting the criteria of the call. You had criteria related to the different axes of the compression. So the complexity criteria, the compression efficiency, the quality. And so we had a set of content, natural image, graphics, desktop content, and we had defined the test procedure with objective measurement and subjective testing. You had 4 or 5 different labs, university research centers participating to these tests to evaluate which was the right proposals. And then from the selected proposals, there was actually the TICO, an evolution of TICO RDD that was selected. And Fraunhofer Institute was also proposing something interesting. There was then 1 year of collaborative work within the ISO JPEG committee to improve and standardize the proposition. And that's how you create a codec at the ISO JPEG committee. And everybody is welcome to participate, by the way.
So you did that development, and I think you also had a focus on in terms of real estate consumption and efficiency of implementation, both on FPGA and CPU and GPU. That was a target you had within the development, yeah?
Yeah, and as an example, so it was really stated, like, for example, on a i7 Intel processor, it should sustain real-time 4K 60p. On Intel or Xilinx FPGA of that model, it should not take more than 50% of space and things like that. So people had to prove that the proposal was meeting these criteria, and it was revised by the groups somehow. Yeah.
Very good. And, so in terms of because we've been talking about latency optimization, and obviously with TICO you got it down to. So do you want to just talk us through what the latency actually is on JPEG XS and why it is that? So what it is that's giving it that latency?
Yeah. So I don't know if I can share again something here, but we know that. Do you see my screen? Yeah.
Not yet. Cosimo, can you maybe put on JB's?
Yes, it's done. Yeah. So according to the MIT, I like to start with that, but it's humans are able to detect latency when it's above 13 milliseconds. So of course it's a full latency from like a key from your keyboard or mouse to the screen. You have the latency of the screen, the latency of the transmission, everything. So that's why like gamers like to use a screen that has not too much latency. Cloud gaming is very challenging. Remote production or remote access to a computer is a challenge for video coding as well. We in JPEG XS we have use a precinct, a wavelet precinct. So the smallest unit can be a 2 lines unit that you will compress. You have a profile that uses 4 lines, and the compression goes to the wavelet, to the coding and the rate allocation. So even if the small unit takes 2 or 4 lines, it means that you will be about 10 lines to encode, 10 lines to decode when it's implemented in a hardware component like an FPGA. That's bring you the latency down to 0.1 millisecond. That would be 0.2 millisecond. I don't think we would have any issue, but thanks to the fact that it's low latency, it's also very low complexity and low power. So this is the side positive effect of that. In software,
sorry, carry on.
Yeah, sorry. Yeah, in software, that was really a challenge to develop like a API able to achieve very low latency. Software implementation are less predictable than hardware. So if you have a jitter from the network, if you have the network interface card, everything need to be the impact of the OS could impact the latency. But we achieve in CPU right now latency that can be around 60 lines end to end. So if you have the right CPU, the right configuration, that's what can be achieved. 60 lines is it's still less than 1 millisecond, so it's pretty good. Yeah, that's
yeah. And going back to kind of the application space, thinking back to the diagram I shared of the facilities interconnected by like IP-enabled WAN connectivity, I think the great thing about a compression that's that lower latency is as soon as you're traveling more than a few tens of kilometers, that latency becomes negligible. The compression latency becomes negligible in the change. So it's about 1 millisecond for every 200 kilometers. So but obviously there's typically quite a lot of buffering in an IP network as well. So you're actually only talking about a few tens of kilometers worth of speed of light in fiber that you're actually costing yourself to do the compression when you've got it down to the excess level. That's a very encouraging.
And also, I mean, that's a good example on the WAN, but on the LAN, like if you have to cascade multiple equipment and to each interface as an encoder and a decoder, let's say you go to an editing step, you have to decode, re-encode, it does not impact the latency. And to go to the next step, that was also a requirement of a codec like that. You can encode, decode multiple times, and at each encode and decode, the PSNR, the level of quality will remain the same. So this is also a good thing of that codec is that it keeps its robustness along multiple compression.
So was there, I mean, going back to that slide I put up on, you only have one chance to make a first compression. Going back to that, so how many concatenations of codec have typically been prescribed or tested or evaluated?
Yeah, that's a nice thing. Let me just stop to share. I will pick another one slide that's nice to explain you what we did. Yes, if I can share again. Yes. So yeah, so we apply actually a completely new ISO standard for the evaluation of JPEG XS. It's a standard code for near lossless quality assessment on both natural and synthetic image. So it's called the flicker test, but we did one change on it. Is that instead of comparing one side of the screen being the uncompressed source and the other side being the compressed interleave with the uncompressed. So we call that flicker because if you have a difference between the uncompressed and compressed, your eyes will be very sensitive to that. We did that, but after 7 encode decoding loop. So we first encoded, decoded, encoded, decoded 7 times the pictures, and that's the way we did the quality assessment with the 4 universities, research centers participating to the assessment, and that's very powerful. In a production workflow, we would say that it could go up to 7 concatenation. Typically, there was an EBU paper a while ago about that. I don't know. 7 is probably a maximum, but yeah.
Okay, that's great. A reminder: if you've got any questions, do come in. I think I've seen one that's come in that's been posted into our chat window. So any other, do keep the questions coming on. We'll come on to them probably in about 10 minutes. One thing I did want to talk about, you talked about, obviously you bought your kind of T-code development as the baseline for what has become JPEG XS. You also mentioned Fraunhofer contributing some technology. One of the elephants in the room that I know has been discussed in the industry over the last few months is the fact that, whilst this is a standard, there is some intellectual property that's tied up in there. So there is effectively some licensing involved as part of this. And I wondered, my understanding is that we haven't, if you like, got to the end yet in the process of that being fully out in the open as to exactly how that's going to work, the licensing. So can you maybe comment to that? Sorry to put you on the spot, and maybe do you have an idea?
I'm here to that for that as well. I would say a few words about intoPIX. I did not, but the company is about 20-25 people, so we are not a large organization. That's about intoPIX. About the JPEG XS standard, you have had several patent proponents. intoPIX is one of them. Fraunhofer is another one, but it's not like in an HEVC battle like
okay.
I don't know if they reach 1,000 patents, but it's not the same story. And for intoPIX, it's just important to find a way, the equilibrium that will not affect the adoption in the broadcast field, but that will also protect us from our somehow innovation in a more consumer electronics market also. So it took us a while to discuss that. This summer, we are now reaching consensus, and we expect that the RAND policy will be fully available at the beginning of January. But I would say the cost is somehow negligible comparing to regular costs, or I would say from all. intoPIX has been in that business for 15 years now, and I don't think that should be an issue somehow.
So what we're saying is there is going to be a global non-discriminatory, reasonable and non-discriminatory licensing.
Yeah. So for us,
at a very low cost point.
the ISO policy is a codec needs to have a RAND policy, so it has to be fair for everybody. So that's
okay.
Yeah.
Cool. Okay, well, we've addressed the elephant in the room. So coming back to the technology, we've talked various times about with compression, about the compression ratio, what compression ratio we can achieve for the use cases. And I know you've got like synthetic and real world applications here that you are looking at applying XS to. But speaking as someone involved in like real-time broadcast, what would you say is the range of compression ratio that can be used for pristine broadcast production?
Mm-hmm. So this is an interesting question. Today the compression has been used in a range between 8:1 down to 15:1. Essentially, what will affect the compression efficiency is the width of the video. So people often think that if I move from HD to 4K, it's 4 times the spatial resolution. So maybe I can be 4 times more efficient. Or we have moving from HD to 4K, we double the lines of pixel. So we have a gain in compression efficiency that as we are buffering lines, we can compress a bit more 4K than HD than SD also. The good news is that you need to compress more 4K than you need to compress HD also. We did some presentation at NAB last year, for example, on 8K at 2 gigabits per second. But that was a 8K smooth footage, and the screen was not big enough to see if there was an artifact because it's 8K also. We did a lot of deployment already of a product using 4K 60 at 800 megabits per second, for example. Because people try to go below the gigabit to use Cat5e, for example, in Pro AV markets. I think Nevion did also some, not experiment, but deployment on the field on HD and 4K already. It's often, I think, 8:1, 10:1, that is the selected bitrate.
Great. Okay, that leads me nicely on. Do you want to just stop presenting, JB? And Cosimo, can you give me the presentation for a second? That would be great.
There you go, Andy.
Thank you very much. I'm hoping you're seeing the right screen. I can never quite tell here. Okay, it looks good. Okay, so what I wanted to do is just talk about because Jean-Baptiste was talking about the deployments and real world experience. So I thought it was worth just sharing some of the experiences that we've actually had in the last little while. So we were very excited to be the first deployers for real of the JPEG XS compression. So that was last August, so August 19, when the world seemed quite normal, right through to now. So we've had roughly like 14 months of experience here. One of the big deployments that we've done is a pan-European what I call federated production network. So this is actually the interconnect of many countries across like Western Europe, and the infrastructure that we're using is basically it's uncompressed video within like the local environment, and then as we're going between countries, we're actually using JPEG XS compression mapped into the 2110 standard as the dash 22 to actually convert to carry the JPEG XS essence separately to the audio. So what we're doing within this environment is we're maintaining the separate audio and video flow essences. And the timing element, which we'll talk about if we have time, we probably don't. But the timing element is great because everything is timed. There is the timestamps in the RTP that's defined in the 2110 suite, which means we have the ability to very easily resynchronize those audio and video flows whenever they arrive at the other elements. So that's one key example in a large meshed federated production deployment in Europe. The other one, which I think it's worth just talking about very briefly, is an example of a very long haul which we did with Riot Games last autumn, and that was actually interconnecting locations in Europe right over to LA. Again, in this example, very specifically, the latency of the fiber completely dominated that of the compression because it's going to take you, I'm guessing we're probably talking about 60 milliseconds to get from Europe to LA at the speed of light and fiber. So those are two deployments. And another one which I haven't got a slide for, which we've been doing quite a lot of trialing on in the last 4 months, and it relates a little bit back to what I was talking about, the ground to cloud and cloud to ground, is we did some field trials with AWS for some US customers back in June and July, where we were actually using JPEG XS compression to get broadcast feeds to and from the cloud. And that involved us using our own Virtuoso appliance on the ground, but also we developed a software, JPEG XS encode and decode software, which was hosted in the cloud. So we could actually use that 8:1, 10:1 compression ratio to actually reduce those broadcast signals to get them up and down to and from the cloud. So a couple of kind of useful examples there. So back to the conversation. I will drop my slide. Do you want to comment, JB, on any other deployments or scenarios that you think are any wisdom you think that's important in terms of how we actually deploy JPEG XS?
Yeah, of course, intoPIX, we are involved in the broadcast industry, but in other industries as well. And the JPEG XS has been adopted, for example, in some medical space for wireless communication. Just to give an example that is completely off this conversation, but because the quality is very good, the latency is very good, and if you are in an operating room, it's very important to have the lowest latency and the best quality also, and you can be annoyed with all the cables also in that room. So that was one of the use cases. We have use cases for HD over gigabit network, just a simple KVM application or 4K over gigabit in a more pro-heavy industries. We have industrial application like you have to transmit at a very low latency camera feeds over private networks. And I think where we have a big work is, as you mentioned right now, is at VSF you have different groups working on JPEG XS for a wider network, and we see both on the cloud production and remote production big interest, and there was a lot of announcement of manufacturers deploying products also last year, and I expect to see a deployment on the field as well, and more announcement later on. one of the last announcement was an 8K trial by NHK, and there will be a white paper presentation during SEMTI today or tomorrow about that also. Yeah.
Okay, very good. And of course, another technology that's emerging that this kind of compression technology may have a place in. I think we're in the situation of still field trialing some of this technology is 5G wireless. So the offer of 5G wireless technology is the offer of massive bandwidths, such that you might even conceive that you could potentially do uncompressed. However, I think it's patently true that, or patently obvious from testing, that the real world bandwidth available in 5G deployments, in some situations, it may actually need a more aggressive compression than the kind of mezzanine compression 10:1 type ratios we're talking about here. But certainly, maybe in NPN 5G networks, non-public networks, there could be some good use cases here.
Yeah, and in fact, yeah, that's great that you are mentioning that, because I completely forgot. But Korean Telecom less than a year ago did the trial of JPEG XS over 5G network. The downlink was good, but I think 5G equipment for uplink right now have still different uplink capacity. So it will evolve, of course. I mean, theoretically, the theoretical bandwidth announced multi-gigabits. If it can reach a gigabit, definitely that will be very appealing for XS. But if it's just downlink from the cloud, you can already think about using JPEG XS for that.
Yeah, very good, very good. Excellent. Right. Okay. I promised that we were going to keep to reasonable time here because I say there are several other events coming up, including our very own Nevion Cisco joint webinar, which is going to be happening on the hour. So do hopefully Cosmo's posted for that, which is good. I think he has. Yes, I can see that. So we've had like 3 different questions come in. I think that I can see so far that have been put into certainly into our panelists thing. So just picking off a couple of these, not necessarily in the order they came up. One interesting point here, which certainly is not my level of expertise, but maybe you can talk about it, JB, is JPEG XS as a file format. It says, does the industry get closer to a ubiquitous live and play out file format? There's been some work specifically on file format work for JPEG XS, which I know I've seen on the periphery, but I haven't really been focused on. Can you just talk to that for 1 minute?
Yeah, I have 3 things. You're right. So JPEG XS can be encapsulated in MXF. The standardization has been done for that. You can also store that as an MP4. The standardization has been done for that. intoPIX did release Adobe Premiere plugin to import and export JPEG XS MXF files from HD up to 8K if you want. There are some initiative at the moment that I cannot speak about it, about mastering a kind of IMF for JPEG XS, so that you will learn more in the coming months, let's say. As intoPIX, we believe that I understand that we still use uncompressed in a studio, but there are always places in the workflow where we need to record and store. So somehow JPEG XS, we have the vision that it could be somehow a mezzanine compression for both transmission and storage, because it has all the right properties to be so. But right now, the main attribute, I would say, where it's more appealing for the market right now, it's really remote production, transmission in LAN or WAN. But it may evolve also.
Great. And I think, when we're talking about typically using a lot, especially over WAN for wide area connectivity for remote production and events, the idea of being able to do effectively a native file capture of those live flows, and that becomes the ingest format, makes a lot of sense. Yeah. Going back to my first compression thing, it's just less concatenated compression cycles there if we're able to do that. So that's good. Somebody else has just posted, I see, talking about post-production has been using things like XD cam at 50 megabits per second for years. Do you think it might be talking about adopting compression within studio facilities, less bandwidth, cheaper network. I mean, my experience from a pure network bandwidth perspective within a local area environment for facilities is, the price point of the network infrastructure and switch fabrics and, dare I say it, even 100 gig fiber interfacing is continually coming down. So I don't see quite so much requirement for that, although I am more and more aware of people considering putting XS as a native compression on cameras and CCUs as well. So is there any comments to that, JB?
Yes, for us, there are different class of cost, I would say.
Yeah.
And I give you a simple example. The latest Intel processor have the capacity to support like 2.5 gigabits on a laptop. I want just to plug a Cat5e cables and be able to get my 2110 stream on my laptop and be able to edit, send it back, and things like that. So it's not just about always about the switch or it's also all the equipment around. And I think that JPEG XS is really designed for that purpose and and is very attractive at that level. And it's also because of that you see initiative like the IPMX at Ames promoting JPEG XS with 2110 and also more HDMI over IP Pro AV type of infrastructure. But there are convergence on the two, I think. We saw a few years ago, and intoPIX has been indirectly involved in that. ESPN decided to really design a building using JPEG 2000 ultra low latency in the building and not uncompressed. So that if you have a large density of stream, also even if it's if everything seems affordable, if you have so many streams to manage and handle, maybe the compression is a good way to squeeze all these streams over a single 100 gig port or as well. So yeah,
that's very good. One other question here, which I think I can comment to: the typical latency JPEG XS encode decoded hosted in AWS cloud for 10:1 compression. So although we did specifically deploy on AWS, there are obviously other clouds available should you need them. Although this one obviously is the one that we've done our testing on. JB talked already about the inherent latency of the software engine, which is like 60 lines or something in terms of the actual processing.
So that's for an encode plus a decode. So if you just do the decode,
I think basically what the main comment at the moment, most of the latency, on a cloud interconnect at the moment, as there would be with anything, is not only the actual routing, the speed of light in the transit. Most typically in the deployments and trials that we've done to date in that space, most of the latency has been consumed in configurable buffering, typically CDI, which is AWS's new cloud digital interconnect. Typically that uses kind of frame-based buffering for the 2110 flows. So typically you're accumulating every time you go one way or the other via a CDI interface, a frame's worth of latency. So you're typically in a 50p world, which is what I like to talk about because it's nice and easy over here in Europe. Then we're talking about a couple of bufferings worth of 20 milliseconds typically as you go in and out of a cloud infrastructure on the time of what we've seen. But going back to Jean-Baptiste's comment about about the slicing and the inherent properties of XS, the only reason that we're seeing those what I call integer frame buffers at the moment in the typical cloud deployments is because CDI, as it stands at the moment, inherently the datagram, if you like, of the video is a whole frame's worth of data. If we look at the evolution of what's happened that we've been discussing from JPEG 2000 to ULL to TICO to XS, we think about that, then there's no reason within cloud infrastructure why we can't move in the future to a striped handoff, and then we could do pro rata latency reduction in a similar manner.
Yeah, and actually that's one thing we had to pass through at intoPIX as well. So our first SDK release we're waiting to have a full frame available in a buffer to compress it as fast as possible. And we change our API to reduce that latency and to be able to compress as long as we have, I think, 10 lines available. We can start to encode or 10 lines or first words of code stream we can start to decode. So that was a change we had to do. So I guess it will evolve, but you need to control the complete pipeline, and that's a big challenging in the software world.
Yep. Wonderful. Hey, our time is up. It's 5 minutes to, but I'm aware there is there's simply stuff happening now, and also very importantly, as you'll have seen, and I mentioned earlier, another Nevion webinar coming up on the hour, which I want you to be able to attend if you like. JB, it's been a pleasure. I'd love to have a real cup of tea with you, face to face.
I don't have time.
But when we're allowed to, let's meet up. Thank you for the pleasure of your company.
In Belgium, it's more Belgian beer.
Okay, whatever. Anyway, thank you so much for sharing with us over this last hour. It's been great to be able to talk with you again. It's always a pleasure. Hopefully everyone has found that useful wherever you are viewing and whenever you are viewing this. It's been great to be together. We're going to do another one of these next month, focusing on testing and measuring 2110 systems. So joining me will be Prim Boone from Fabrics. We're going to be sharing and having a nice cup of tea together then by the fireside again. I'll go collecting some logs in the garden ready for that one. Thank you very much. Stay safe, everyone. Thanks again, JB, for your fantastic input. Don't forget, if you are able to join our webinar with Cisco that's on the hour now. If not, have a great rest of your day wherever you are. We look forward to seeing you again soon. Don't forget to go to the Nevion website and the intoPIX websites to check out information. Cosimo, if I can just put this last slide on, if you could just do that for me,
Carry
that
on.
would be really great. Just waiting for him to push that up, just so you've got the contact details up again. Can't quite see it yet. Have you given that to me yet, Cosimo?
Yeah, you have it.
I don't have it yet.
I mean, as I never removed from you, I can.
I don't have the ability to do it yet.
Okay, you go.
Okay, wonderful. Thank you very much again. Thanks, everyone. Thanks, JB. Have a good rest of your day. Stay safe. Take care. Goodbye.
Goodbye. Bye-bye.